Take a look at these two chocolate bars. The first bar is divided into two equal parts, and one part is shaded. That gives us 1/2. The second bar is divided into 4 equal parts, and 2 of those parts are shaded. That gives us 2/4. Now here's the big question. Do these fractions represent the same amount? They certainly look different, but if the chocolate bars are the same size, the shaded amounts are exactly equal. That means 1/2 and 2/4 are equivalent fractions. By the end of this lesson, you'll be able to recognize equivalent fractions and create your own equivalent fractions. We'll use pictures first, then number lines, and finally multiplication. So even if equivalent fractions feel confusing right now, don't worry. We're going to build the idea one step at a time. The word equivalent contains the word equal, and that gives us an important clue. Equivalent fractions are fractions that may have different numerators and denominators, but they represent the same value. Think of them as different names for the same amount. Just like $1 and 4/4 have different names but the same value, 1/2 and 2/4 are different fractions with the same value. Before we continue, there's one important rule to remember. The wholes must be the same size. 1/2 of a large pizza is not the same amount of food as 1/2 of a tiny pizza. They're both called 1/2, but the actual amounts are different because the wholes are different sizes. When we use models to compare equivalent fractions, we need to begin with equal-sized wholes. Let's look more closely at 1/2 and 2/4. The top bar is divided into 2 equal parts, and one part is shaded. The bottom bar is divided into 4 smaller parts, and 2 parts are shaded. Notice that the shaded sections end at exactly the same point. The pieces are different sizes, but the total shaded amount is the same. So we can write 1/2 equals 2/4. Here we have 1/3. The whole is divided into 3 equal parts, and one part is shaded. Now let's divide the same sized whole into 6 equal parts. To cover the same amount, we need to shade 2 of those smaller pieces. The shaded amount didn't change. Only the number and size of the pieces changed. Therefore, 1/3 is equivalent to 2/6. Your turn. Which of these models shows a fraction equivalent to 2/3? Pause the video if you need a little more time. The answer is 4/6. When we compare the models, 4/6 covers the same amount of the whole as 2/3. So 2/3 equals 4/6. Equivalent fractions can also be found on number lines. On the first number line, we locate 1/2. On the second number line, we locate 2/4. Look at the 2 points. They line up perfectly. Fractions that land at the same point on a number line have the same value, so they are equivalent. Let's try another one. First, we locate 2/3 on the top number line. Then we locate 4/6 on the bottom number line. Both fractions land at the same point. That confirms that 2/3 and 4/6 represent the same value. Now let's look for a numerical pattern. To change 1/2 into 2/4, we multiply the numerator by 2. 1 times 2 equals 2. Then we multiply the denominator by the same number. 2 times 2 equals 4. The key is that we must multiply both the numerator and denominator by the same number. That keeps the fraction's value equal. You might be wondering why multiplying both numbers doesn't change the fraction's value. When we multiply the numerator and denominator by 2, we are really multiplying the fraction by 2 over 2. And 2 over 2 equals 1 whole. Multiplying a number by 1 doesn't change its value. That's why the fraction keeps the same value, even though its numerator and denominator change. Let's find the missing numerator. We have 3/5, and we want an equivalent fraction with a denominator of 10. First, ask, what do I multiply 5 by to get 10? 5 times 2 equals 10. Since we multiplied the denominator by 2, we must also multiply the numerator by 2. 3 times 2 equals 6. So 3/5 is equivalent to 6/10. We don't always have to multiply by 2. We can multiply by any whole number as long as we use the same number for the numerator and denominator. Here, we'll multiply both parts of 2/7 by 3. 2 times 3 is 6, and 7 times 3 is 21. Therefore, 2/7 is equivalent to 6/21. A fraction can have more than one equivalent form. If we multiply 1/4 by 2 over 2, we get 2/8. If we multiply it by 4 over 4, we get 4/16. We could continue this pattern again and again. All of these fractions are different names for the same value. Here's a common mistake to watch out for. A student might multiply the numerator by 2, but forget to multiply the denominator. That changes 2/3 into 4/3, which is a completely different value. To create an equivalent fraction, whatever you do to the numerator, you must also do to the denominator. Now it's your turn. Complete each equivalent fraction. Pause the video and work through all 3 before checking your answers. Ready? For number 1, 3 times 3 equals 9. So 1 times 3 equals 3. The missing numerator is 3. For number 2, 4 times 2 equals 8. So 3 times 2 equals 6. For number 3, 2 times 4 equals 8. That means we also multiply 5 by 4, giving us 20. How did you do? Let's decide whether each pair is equivalent. For the first pair, 2 times 3 equals 6, and 3 times 3 equals 9. Both numbers were multiplied by 3, so the fractions are equivalent. For the second pair, 3 was multiplied by 2 to get 6, but 5 was multiplied by 3 to get 15. The same operation was not used for both parts, so these fractions are not equivalent. Here's your challenge. Can you find 3 different fractions that are equivalent to 3/8? Choose 3 different numbers and multiply both the numerator and denominator by each number. For example, multiplying by 2 gives us 6/16. Multiplying by 3 gives us 9/24. Multiplying by 4 gives us 12/32. Your answers may be different from mine, and that's okay, as long as you multiply the numerator and denominator by the same number. Let's review what we learned. Equivalent fractions are different fractions that represent the same value. When we use equal-sized models, they cover the same amount. On a number line, they land at the same point. We can also create equivalent fractions by multiplying the numerator and denominator by the same number. Remember, different numbers, same value. Before you go, complete this quick exit ticket. First, find the missing numerator in 2/3 equals something over 12. Next, decide whether 3/4 and 9/12 are equivalent. Finally, explain equivalent fractions in your own words. You can say your explanation aloud or write it down. If you can show that 2 fractions represent the same value and explain how you know, then you've met today's learning target. Excellent work. If this lesson helped you, give the video a thumbs up, Subscribe to OLS Math Academy and turn on notifications so you don't miss our next lesson. Keep practicing, keep believing in yourself, and remember, you can succeed in math. I'll see you in the next lesson.